Hello everyone, welcome to your next class. In this one, we're going to do something that's really interesting or unique with random forests in that we can determine how important specific features are or were in the determination of whether a decision tree is like really good or not, okay? Or we can say like, okay, so we have all of this data, we know that we have petals and sepal lengths and widths. Which was the most important feature for determining a setosa for a virginica? This is unique because most machine learning models don't have this feature. It's just kind of an aspect of the way that they're calculated. However, random forests do because of how you do that decision tree making. You can use variance and sum up like how much of gene inequality exists within the decision trees that you're building to determine A, what was the most effective decision tree, and B, what features were most important in its splitting process. And this is really useful and important because with machine learning, having like when you have dozens, if not hundreds of different features that go into your evaluation, you might want to know, okay, which features are more important than others? And do those features actually make sense for a given problem? If they don't, maybe you can have an evaluation of, okay, yeah, we have this accuracy, but maybe the machine learning model didn't learn what we actually were expecting it to learn, or we were hoping it would learn. It found this other weird pattern that we didn't expect in our data that was able to give it some high degree of accuracy or classification that isn't actually generalizable to the real world. So with that, we're going to spend a little bit of time learning how to do that and showing you why this is cool and important, okay? So in this class, we're going to learn how to create a feature importance bar graph. This is called a histogram. Essentially, we're just going to take all four of our features. We only have four for our iris data set, and we're going to run our random forest model and then generate which features were more important than others and how much variance was there in that importance. So we could say, okay, the features of the flower as opposed to the features of the leaf maybe were more important than others. Okay, so with that, we'll then talk a little bit about definitions, just a bit of a reminder of that. Standard deviation is probably the only thing that we need to really remember and learn. We're going to remember that standard deviation is related to variance, and how standard dev works is basically the degree to which values are spread from the average. If you have a high degree of standard deviation, that means that the values are going to be very spread around the average. They're going to be very different than the average, whereas if you have a low degree of standard deviation, the values that you have in your data set are typically very stable and very close to the average. They don't move that much. So that's all we really need to know in terms of definitions, guys. Let's move into our syntax because there's a little bit more code that we want to play with in this section. So in this one, we still have most of our packages that we had from last class, except we also have our matplotlib, our plotting feature, so that we can create a simple bar graph, all right? Just like our last section, we initialize our random forest model. We set the estimators to 5 again. And in this example, I'm passing in another parameter called random state. Basically, because we build a random forest, it will randomly select things within our data set. When we set a random state, this says, okay, we basically are setting like, we're making our randomness stable. So we set a random state, we set like a random pattern, and we keep that random pattern. So we're saying use random state 0, you can put in any number there, and it's just going to continue to select features in a consistent way as opposed to randomly. It's still doing it randomly, but we're setting what random selection is actually occurring, okay? Next, we load our iris data set like we did last time. We then fit the data like we did last time. We set in our x, which is the 4 features in for our iris petal lengths and sepal lengths and widths. We then pass in the target, which is the label for that specific flower. Is it a virginica or a setosa? And that's how our random forest is built. Our random forest at this point has technically been made. Okay. Next, we want to extract just one tree because we want to show you how to build that bar graph. We can't create a bar graph for all the features. We would have like hundreds of different random decision trees in that, and it wouldn't be easy to read. I just want to show you one of them. Okay. So how we do that is we have our estimator here. We select our one tree that we're going to extract some information from. We then calculate the standard deviation for our trees. So how we do that is we go, what we're doing is we're doing a list comprehension here. So for all of the trees in our random forest, for each tree basically, we have the feature importance right here, and then we calculate the standard deviation for each of those trees. So if I print tree standard deviation and I quickly comment this stuff out so we can read that. There we go. What do we get here? We get we get the standard deviation for each of the features for all of the trees. So this is saying to us that there was a lot of variance for feature 1, which I believe is petal length, but much less variance for petal width, and so on and so forth, guys. Okay, that's what's going on here. We are going through each tree, finding the importance for each of them, and then calculating the standard deviation for each column. All right, that's all that's going on there. We then select the importances for each of these features. So we go model.featureImportances, which is if you go model dot and then go through the different features that are the different methods that are available for this object. If you go to feature importance, you'll in fact get that. So let's see what happens when we print the feature importances. So it says that feature 1 has this value of importance, feature 2 has this, and so on and so forth. So it appears that our final feature, our last feature, is in fact the most important one in order to determine one class for another in our random forest. All right. The next thing we do is we build some indices. So basically, we're just we're just like setting what the specific features are pointed to. It's kind of like we're setting the indexes so that we can then create our bar graph later. That's what this line is doing here. And then we just do a very quick calculation for how many different features are in fact being used in our random forest model. And there should be 4 here. So I'll print what indices look like, and I'll also print what total features looks like. Total features, here we go. So this is saying, okay, so in this random forest model that we're looking at here, we have our last feature, then our first features, our third feature, and our first. And there are, in fact, 4 features altogether. So if we then printed, let's just print instead our importances, we now know that, okay, so this is, in fact, the second feature is the most important feature because these were selected at random. Remember, guys, that's how a random forest works in the first place. So we're finding out we have these feature importance numbers, but we need to know which feature they are pointing to, and that's what these 2 lines are doing. Okay, so what we can then do is I'm just doing a very simple for loop here that is going to print this all out for us so we can read it easily. So we just kind of go feature ranking, and then we say for all the features we're going to print the value as well as what the feature is. So here it says feature 3 has this importance, and it's all ordered by how important things are. So feature 3 is the most important, then 0, then 1, then 2. So technically, we can have different features having different numbers here. So what we could do is maybe go. We have f+1. We might want to go, +1 here, and that will actually make this not 0 index. So feature 4 is more important than feature 1, then feature 2, then feature 3, then feature 2. Okay. Then what we do is we want to print this. So we want to actually visualize this. We want to create a bar plot, all right? So we have all the data that we now need in order to create the bar plot. We have our y value. We also have our standard deviation value that's going to create the bar that's associated, the line that's associated with each of these features. If you took my previous class on data science in Python, we spent a little bit of time going through what a bar graph looks like and how you can interpret that histogram. So do check that section out if you have that class. Otherwise, I'm going to show you how this all works here, how to build a plot in Python really quickly. I do recommend checking out my class on that because I spend a lot more time than I am here. So I'm creating a figure. I'm saying, and create this figure object. I'm saying the figure's title is going to be feature importances. I then create a bar plot. I say that there are 4 features that are numbered from 0 to 3 or 0 to 4. 0, 1, 2, 3. I then give it this is like giving it the X number. I then give it the Y value, which is how important that feature is, and like passing through all of these indices in the proper order, because we ordered them properly up here. I say I want the bars to be red, and I wanted to put in the standard deviation lines, okay? Which will be associated with each bar. It's going to show how much variance there was for that importance value. So even if we have this, super important value, which is 0.62 here, if it's just like really important, but there's all kinds of variance to it, that means that we can't reliably use this all the time, because this number is always changing. Like there's a lot of difference from the average. So it might be very important, but it's still going to have a lot of error associated with it. So it's maybe not the best predictor, even if it appears to be the most important, because the reality of the data is that it's not that stable. And then lastly, this is just a positioning feature parameter. It's saying I want to center each of these bars so that they're easy to read. Lastly, we adjust the ticks, the way that our plot is labeling things on the bottom by using .xticks here. And then our last line here is to show what this is going to look like. So why don't we just run this and see what happens. We have a small error. Oh, it's saying the standard deviation is not defined. Okay, that makes sense. So how we do that is, we should probably go tree STP. There we go. And that works just fine. All right. So what we see here is that we have our 4th feature. We can probably, rename these if we wanted to, but let's just leave it as it is. Our 4th feature is the most important, followed by our 1st feature, followed by our 3rd feature, and then our 2nd feature. And you'll notice that even though our 4th feature is the most important, it does have the most variance, but not by much. If you look at our other bars here, we're seeing that they're pretty close in terms of the amount of variance. So therefore, I would say that I would interpret this decision tree as, or this random forest as, okay, our final feature is definitely the most important. There does appear to be a high degree of variance with it, but because the amount of importance is so significantly higher, we can say that I would interpret this as, okay, this is a decent feature. This is something that maybe we want to look at a little bit more as like the most important variable for determining what kind of flower we have. And this is unique. This is not something that you can do with, let's say, a k-means clustering algorithm or support vector machine. You can't just easily determine which features are more important and by how much. The interpretability of those models is a lot harder to interpret. So learning this about random forest, it's such a robust algorithm. You can do so much with it, and there's a high degree of interpretability. So I really do recommend learning random forests first as for machine learning, because you can use any kind of data. It can be categorical, it can be linear or logistic, and you can actually do some interpretation, which you're not necessarily able to do with other models. Okay, guys, let's do a recap. So what did we learn today? We learned how to interpret features from random forest models. So we have some data, we've done our random forest modeling, we have some classification, we could maybe do like a prediction score or something like that, which we will do in our next section. We haven't done a lot of like evaluating how well a model is doing its classification. So in our next section, we're going to learn how to do that with support vector machines. So that's kind of the bottom rung of our data science workflow. If you remember that from previous classes, we're going to spend a lot of time on that for our next chapter. We learned how to visualize feature importance for random forest models using a histogram, which is a really unique thing that you can't do with other models easily or necessarily. And we did some basic statistics reminders, which is like reminding you what a standard deviation is. So with that, guys, thank you very much, and I'll see you next class.